All right, guys, so we are going to work through the notes from 9.5 with complex numbers. And on your notes, I failed to write it on here, so I'm actually just going to draw it in, and I've got something to write with. So I'm going to start with the first one. Oh, might help to have power on my tablet. Okay, there we go. Now I can write. Okay, so number one. Whoops, why didn't it write? Number one is 3i squared, and I wanted to write it to simplify. So I squared, if you remember, I is equal to the square root of -1, so I squared is -1. So that makes this -3. Number two is 7i times 4 minus 6i. All right, so this you want to distribute, and you get 28i minus 42i squared. And so this I squared becomes positive because I squared is worth -1, so it's 42 plus 28i. I is always written last. Number three, this one is 2 minus I. Whoops, not -2. I got to fix that. Eraser. It's just 2 minus I times 3 plus 2i. And the way you do that one, we're going to take advantage of these squares if I can. Well, I said I was. I lied. I think my tablet's a little crooked, which doesn't help me at all. All right, and so I'm going to get 2 minus I and 3 plus 2i. The order at which you put these on there does not matter. That's 6, 4i, -3i, and -2i squared. Now be careful because this one on the end with a -2i squared, this becomes just +2. I can add my diagonals, which gives me 8. And then adding the diagonals in the other way gives me a plus I. Final answer. Okay? All right, so that's stuff from last year. All right, so let's look at this year. What are we doing? Well, we're going to take these and we're going to graph them. So we have 2 minus 2i. So if I go 2 and a -2i, so it's right in here. I'm trying to do it. I'm at an angle. All right, so this is my real number line. This is my imaginary number line, IMAG. There we go. But these are my real numbers. I meant to do a double backed R. That one came out really nasty looking. All right, so this is number one. Number two is -4 plus I, which is right here. This is number two. Number three, you can pause this and do these and see if you can get them all right. That's number three. Number four, -1, -3. Number four. All right, so you have them all. Now what I'm going to give you is a little bit of heads up. I'm kind of, spoiler alert, I'm going to ruin this for you. The absolute value is the distance. So this piece right here, to find that distance, is the square root of a squared plus b squared. All right, which looks a lot like magnitude, right? And we can also find an angle for this guy by using an inverse tangent. Okay, and we're going to talk about that as well. All right, if you know this point, it works the same way all of our other points did before. All right, so just saying, this is, you can see some similarities to vectors. All right, going on, the absolute value is, it's just the square root of a squared plus b squared. So if I want to find the absolute value of this guy, all I do is 2 squared plus 3 squared. Now, technically, it is truly a -3 squared, but most kids forget the negative, so I have a tendency to not write that negative in there. 2 squared is 4, negative 3 squared is 9. Add these together, I get the square root of 13. And you can turn that into a decimal, which I'm not going to. All right, going on. The trig form of z is equal to a plus bi looks like this. Now, you can just memorize this. I can have it on the board for you. But technically what this is doing, this modulus, or the r, remember, it's the square root of a square plus b square. And that is a lot like our magnitude that we had from before. And if you distribute this, you get r cosine theta plus I times r sine theta. And if you think of that like the magnitude, didn't we find our x and y with the magnitude times cosine and the magnitude times sine? The answer is yes. All right, your argument, now be careful, in your notes it just says theta equals. Well, I wrote tangent of blank. So that's b over a, but you better get your inverse tangent in there, okay, of b over a. So that's how you find it. All right, let's go on. So what's the modulus and what's the argument? Oh, well, it might help me. Oh, shoot, what did I do? Something happened. Okay, I'm there. Whew, sorry, I hit something on my computer and something went crazy. But anyway, this is the modulus. And the argument is 30 because it's the degrees. The argument is 30 degrees, okay? Now, write the complex number in trig form. So you've got to think about where this guy's located. So first period, listen up to this. All right, so if I'm at -2, -9, it puts me right here. I kind of forgot to point that out of where this is located. Okay, so what I did do correctly is I went ahead and I found the r, which is the square root of 2 squared plus 9 squared. And you can call this the absolute value of z if you like. All right, that's the same thing. So 2 squared is 4, 9 squared is 81, so this is the square root of 85, or the decimal, don't care. This one, I do tan inverse of -9 over -2. Now, I know good and well that is the inverse of tan inverse of 9 over 2 because they cancel with the negatives, and I get 77.5 degrees. Be careful though, 77.5 is located here, and that's not what I need. I need this angle. And so how do I get it? 180 plus 77.5. So add the 180, I'm at 257.5. So theta is 257.5. So if I'm going to write this in trig form, go back to the paper if you need to, but z is equal to this piece, square root of 85, times cosine 257.5 plus I sine 257.5. And the bell just rang and I'm going to try to finish. All right, on this one, write this in standard form. All you have to do is distribute back. So one way to do this, you can write it as 2 cosine pi over 4 plus 2 sine pi over 4 times I. Okay, but I can tell you right now, this is going to be 2 times square root 2 over 2. That cancels. Plus 2 times square root 2 over 2. That cancels. So the answer is square root of 2 plus square root of 2i. All right, example 4. Now what is the cis? This is the same thing as cosine pi over 6 plus I sine pi over 6. So the cis comes from the C, the I, and the S. Okay? So this is going to be 2 pi over 6 is, come on in, baby, you're fine. It doesn't matter. Pi over 6 is located, hold on, I got to do this in my head. That gets me in trouble. Pi over 6 is this guy. He's the square root of 3 over 2 and 1/2. So that would be 2 times square root of 3 over 2 plus 1/2 I. So distributing that, we're going to get square root of 3 plus I. Final answer. All you do is distribute. Last thing we have to learn is, this is the formula. You multiply here and you add the degrees. Okay? So they add. That's what this is telling you. All right, so let's look at the last example that I need to get through. So to find the product, I'm going to multiply here, and that's going to give me 24. And you can write this as cosine 420 plus I sine 420. But you can't leave this over 360 degrees. So you've got to subtract off the 360, which gives you 24 cosine of 60 plus I sine of 60. Now, this is the last time I'm going to take my time writing it out. This is the same thing as 24 cis 60, and we're done. All right, let's look at the next one. I'm going to do this one super fast. 16 cis SIS of, okay, so I need to go into my calculator and take 2 pi over 3 plus, I've got my TI-30 multi-view handy here, 11 pi over 6, enter, and I get 5 pi over 2. 5 pi over 2. Now this does not fit because it's 2.5 pi, so that's the same thing as pi over 2. I've got to subtract minus 2 pi here, all right, because it's too big. So I got 16 cis, well, I wrote 16 twice. Good grief. 16 cis CIS of pi over 2. Final answer. Next one, multiply here, 12 cis. I just need to add these. When I put them in the calculator, I promise it comes up as pi over 3. I'm done. So the next piece, and I'm going to put it there for a second, and you can pause it. This is the homework that you need to do. Have a good one.